Presentation from DoITNow. We have Valentin Planes, who was unfortunately not able to make it. He's on a Zoom meeting with us, but to start it all off is Vittorio.
Hi all, my name is Vittorio Marchetto. I'm the Business Developer Manager for DoITNow in Italy. First of all, I want to thank the organizer about the invitation in these events, because for us it's always a good opportunity, a pleasure to be here for sharing information and topics about HPC and AI workflow. With me today remotely, there is also Valentin that will carry out the presentation showing you the technical details about our speech. Before to start, only some numbers about our company. So DoITNow is a company with an important footprint in EMEA. We have office spread in France, Germany, Italy, and Spain. And we have also a branch office in New Zealand and a support team that can support our customer in the USA and in Brazil. This allows us to have more than 130 people that are dedicated to support our customer 24 hours for supporting our customer for HPC and AI purpose. So Valentin, can you switch on the next slide? Okay. About some number, we have a company with 100% independent capital. And as I said before, we have more than 140 people dedicated to support our customer for HPC and AI workloads. And we have a huge experience on HPC, more than 30 years. And currently we are managing more than 200 customers in different verticals. So this means that we cover verticals like automotive, aerospace, chemical, oil and gas, manufacturing, research, and university. We also installed 5 clusters that are in the top 500 ranking cluster. And so we are focused on this activity. Valentin, can you switch, please? Okay. For closing, our services are focused on consulting, so we can start to help our customer designing the final solution, HPC or AI solution, starting from the scratch, or we can help our customer for improving the solution that they already have in place. And after, we can also install what we design with our customer, starting from the operating system, tools, drivers, and so on. And we configure also the tools that we install on the different cluster. We can provide support to our customer that can be a support on an on-demand basis or support services that are tailored based on our customer's need with specific SLA. And last but not least, we have an R&D teams that is dedicated every day to optimize and to find the solutions to propose to our customer for improving their activity. So I finished. I leave the stage to Valentin for the speech. Thank you.
Thank you, Vittorio. Can you hear me?
Yes, can we hear you?
Nice. So first of all, thanks. I would like to thank the HPC AI Advisory Council and all the organizers of this conference. It's a real honor for me to be here and to have the chance to share our experience with all of you. So today I would like to talk about a topic that is very important to us, something we believe is transforming the way organizations approach this new generation of AI, and we would like to illustrate it through this presentation and seeing healthcare support system with Agentic AI. This is based on our work for one of our healthcare customers, but the idea applies to many other sectors too. We will see how we combine HPC infrastructure with generative and agentic AI to dramatically improve support operation. So let me give you a quick overview of what I will present today. So first, we will start with the healthcare context to explain the environment we are working in. Then I will show you the typical customer support workflow to explain and highlight challenges we are trying to solve. After that, I will make a very short history about what we call foundational generative AI and the agentic AI that is running just behind and is bringing a new level of autonomy and intelligence in computer science. I will give you also some insight about the infrastructure that support the solution to also illustrate that what we are capable of at DoITNow. And I'll give you a quick software stack overview to contextualize the technical aspect of the solution. Then I will walk through our agent design and how it goes when they act, and show some impact and success metrics, and then we will conclude. So the context. So the context, we need to understand in the healthcare context that the time is absolutely critical. They must submit, in general, detailed documentation to health authorities. So managing clinical trial data and stay compliant with very strict regulation, all with zero or close from zero downtime. So support services in this field must be fast, accurate, and available. But unfortunately, the reality is quite challenging. First, there is an overload of documentation. So we have hundreds of pages, different format, multiple systems. It becomes very hard to support teams to find the right information quickly. Second, the workflow are very fragmented. Different departments use different tools, have different processes, and communication is not always smooth. So what often happens is that we call the ping-pong effect. A ticket bounces from team to team, each one saying, not our responsibility, and please forward to this other group. And we are wasting time and frustrated everyone that is involved. So with this challenge, it's clear that traditional support systems are not enough anymore. And we need something more intelligent and more proactive. And this is where the innovation comes in. So just to give more context about the support. So typically, the process follows three main steps. So the first step is to understand the issue. So the support agent needs to read the ticket, of course, interpret what the customer is asking, and try to collect enough context. Sometimes the request is clear, sometimes not. It's a bit confusing. Secondly, they go into investigation. This means searching across documentation, logs, previous cases, maybe even checking with other teams to figure out what is actually happening, like making a diagnosis. And finally, the first step is to communicate the solution or resolve the issue and communicate after to the user. The support agent must write a clear and correct answer, often translating technical finding into something that the customer can easily understand. So even if the workflow is clear on paper, the execution can be slow and heavy. And this is exactly where we believe AI can play a key role, basically. So a few words about what we call foundational generative AI. It's a technology I'm sure many of you are familiar with, thanks to ChatGPT. So generative AI models, and in particular LLMs, are trained on huge amount of data. They can create new concepts by predicting what comes next. This makes them very creative, as you know, and they can help us draft email, generate documents, write reports, and so on. But there is a limitation. Even if the text sounds smart, the model doesn't really understand the context deeply, cannot really plan as is. And we don't just need AI that can write or summarize. We really need AI that can understand what is happening, make sense of the situation, and then do something about it. That's why we go a step further, and this brings us to the next part, agentic AI. So now, unlike generative AI, which is mainly focused on producing content, agentic AI goes much further. It doesn't just generate responses, it can understand a situation, make decision, and even take action on its own. So there are main four capabilities of perception. It sees and understands the context. It can take in structure or unstructured data and recognize what's going on. Reasoning. It can evaluate that data and connect the dots and make sense of the complex scenario. And also planning. Based on that reasoning, it can decide what steps should be taken next. And also acting. And it doesn't just suggest, it actually executes the plan, triggering workflow or updating system automatically. Of course, this kind of intelligence comes with a cost. So computational demands are much higher than for traditional AI. And we are now talking about systems that need to maintain memory, track objectives, run decision trees, interface with APIs, and work in real time, mostly. And to support this level of AI, you need the right foundation. This is where infrastructure becomes critical. So for our customer, now that we have understood what Agentic AI can do, let me explain how we build the system to support it. So the solution runs on a robust cloud infrastructure based on AWS with multi-region deployment to ensure high availability, where the system must be fast and always available. We use Kubernetes cluster to manage our service. This gives us flexibility and scalability, so we can deploy and scale efficiently. And when it's come to computing power, we rely on GPU-based instance, including NVIDIA H100 and A10 GPU for lightweight workflow. These are essential to handle the high demand for agentic AI for our customer, especially for maintaining real-time interaction. But the hardware is not enough. The software layer is also critical, of course. So that's why I would like to give you a stack overview. So one of our key design choices is to rely on open source components. Why? Because open source gives us transparency. We can see how things work under the hood, and also it gives us full control over the flow, system behavior, and deployment. So in detail, we are capable of supporting most popular inference engines, like VLLM or TGI from Hugging Face, but we are also able to plug proprietary APIs if for specific use the customer need it. So if you want to use external API like OpenAI or Mistral, you can also, we have an API that can federate all the access. And for monitoring part, we are using Lanxious capabilities. It's a popular open source framework for monitoring. For orchestration part, we are using LangChain, which is quite common and quite compatible with a lot of other framework. And under the hood, we are using LangGraph logic, which is an extension of LangChain. So this stack is compatible with data privacy. That is healthcare in the healthcare domain is quite important. And so for our topic today, currently we are using at the core of our solution 2 key models. So first, the Llama 3 70B models, which is a very powerful open source language model from Meta. And the second is GTE version 1.5, which is coming from Alibaba. It is used as an embedding model. So it's dedicated for mainly tasks around retrieval and system processing, document system processing. So depending on the customer need for control or compliance, the stack can be deployed either in the cloud or on premises. So next, let's speak about our agent design. So here you can meet Max. It's our documentalist. It's an agent that is called Agentic RAG, which stands for Agentic Retrieval Augmented Generation. You may already know a standard RAG. It's retrieve information from a database or document and then uses the LLM to generate a response. But Agentic RAG goes a step further. Our agents don't just fetch information, they understand the context, decide what is relevant, and then also apply it actively to help the user. This agent connects to multiple sources of information, including raw PDF files or Confluence pages, internal knowledge bases, and so on. So let's meet Sam agent. So Sam agent is there when a user submits a ticket through ServiceNow. So it can connect to ServiceNow, basically, which is a popular solution for ticketing. The agent helps immediately and it can detect what the issue is about, retrieving similar cases or finding related documentation, and even suggests a clear and complete problem description, all without needing the user to search manually. So instead of writing a vague or incomplete ticket, the user is guided to submit something that is more accurate. And this alone can save hours per case. Now, let me show you those agents in real action. So this is a sequence it's a screenshot of a sequence that you can see where Sam and Max are collaborating to assist a user with submitting a new issue. So the user, you can see on the top of on the left, is concisely describing his problem, but like you can see, it's not fully clear yet. So the first agent Sam step in, and Sam is focused on user interaction and ticket clarity. So it politely asks for more precision, helping to guide the user and collect the missing details. But at the same time, Sam doesn't work alone. Behind the scene, it sends a query to Max, our documentalist, who specializes in retrieving knowledge in the technical documentation. And Max searches across internal documentation and finds a similar case that may be relevant and communicated the information to Sam as an answer. And then Sam is gathering the messages. And we can see clearly on the right that the response that Sam provided to the user include both the clarification guidance and the insight retrieved by Max. So together, they produce a response that is pretty accurate and tailored to the situation. So I would like to propose you to deep dive in success metrics. So there's some KPIs about Sam and Max combined. First, we have reduced ticket resolution time by 50%, That means user gets help twice as fast. Second, we've lowered manual workload by 55%. Support agents are spending more time focusing on real problem solving. And third, our system reached 87% accuracy in retrieving relevant information for each case. That's a strong indication that the agent is also reliable. And it's important to say, Agentic AI is not here to replace human, it's here to enhance human teams, expanding their capacity, improving their speed, and helping them making better decisions. But to embrace this future, we also need to prepare. This system requires more computing power, smarter infrastructure, and a mindset focused on the collaboration between humans and intelligence agents. And with that, I'll move to a few final thoughts in the conclusion. So what we've seen today is that Agentic AI is truly transforming healthcare support. It acts as a new kind of collaborator, I would say, boosting team capacity, especially in terms of response time. And it's exceptionally effective at retrieving accurate information from vast knowledge databases. So, like I said, it doesn't replace human expertise, it complements it. It helps teams respond faster with more accuracy. But we must also look at the future. As this technology continues to evolve, computational demands will grow. So to keep pace, we need to invest in robust, scalable infrastructure, not only in hardware, but also in smart orchestration that can handle those new needs. So be prepared for the current revolution. Thank you.
Thank you.
Thank you.
If you have some question, I don't know if we have time for a few questions, but don't hesitate.
Let's just take a look.
Otherwise,
Does
we
anyone
can
have
keep
any
in touch
questions?
via emails or LinkedIn.
Can you hear me okay?
Is there a question, Valentin?
Hello, can you hear me?
Yeah.
Okay, all right, 1 second.
Hello, yeah, this is Tomas from CCS. Thank you, Valentin, for the presentation. I just wanted to ask if, could you give an overview of what was the first agent built on? I'm talking about the rack you mentioned too, with names, but one was parsing raw files and Confluence pages.
Can you repeat, please, about the RAG and Confluence pages?
If you could tell on which technologies you built the first of the agents you mentioned.
Mm-hmm.
The one that was parsing Confluence pages. I don't remember, it was SAM or the one before.
It was for Max, the documentalist part. So yes, we built a connector to fetch data from Confluence pages that are basically already markdown formatted. So it's quite convenient. It's not the most harder part. I don't know if it's answering the question.
No, that's good.
Okay, cool.
Thank you, Valentin. Appreciate it. Glad we were able to make this work.